Hello everyone, my name is Alexander Zelenin. I am experienced software engineer and today I will explain how to solve problems.
Hi, my name is Alex Khaletsky. I'm newbie and I'm gonna listen very careful, Alexander.
So for today we are going for a new topic, sorting, and the first task called bubble sort. Before we will go to task itself, I want to explain a bit about. First of all, I want to mention the plan for today. We will start with determining what is sorting, what is bubble sort, why sorting is important. Then we will go through the problem itself. Then we will find out our algorithm to solve the problem. Then we will determine complexity of our algorithm. After that, we will write the code, test it, and that's all. Okay, so
Great plan.
yep. Sorting is one of key points of programming along with data structures and with searching. So searching and sorting generally is very close to each other. Almost every algorithm do some kind of sorting or searching of information. When you use any kind of software, it will search for something or sort some kind of data or whatever. The easiest example is Google. It sorts some information in some order and provide this information to you, so it's find this information. And it easy when you have like 100 elements, but when you have 1 billion elements, it's not so easy to search through them. So today we will learn bubble sort. It's easiest implementation of sorting algorithm that like super simple. It is not so efficient, but since it's easy to implement, it's possible to use like for junior developers in some parts of code where it's necessary. So let me open Paint and draw something a bit. So let's choose some example. So for example, we have array of 3 items, 3, 2, and 1. Let's have a bit more items, at least 5 of them. Let it be 5, 3, 2, 4, 1. So with bubble sort, we will go through our array multiple times. Every time we start with the first element of the array, and we will have something like is there a, yeah, we'll have something like window of 2 elements, and these windows on each step will move like for next 2 elements. So at the start we compare first 2 elements, 5 and 3. 5 is greater than 3, so we will swap this element with each other. So after this step we will have 3, 5, and other elements doesn't change. After this we move to the next step, like 5 and 2. We compare them, 5 and 2. 5 is greater than 2, so we swap them again. After this, 2 goes here, 5 go here. We move our window again, one more time. So we compare 5 and 4. 5 is greater than 4, so we will have like 4, 5. And the same for the last step, we will have like 1, 5. So after this, we will have like 4, 2, 3. I think the name of algorithm is like self-explainable. Why it's bubble? It's bubble because we have something like bubble, and this bubble like move to the end of array. So like the heaviest elements always move to the end. It's like go up. And lighter elements move to start. So after this step, I just want to continue a bit what will happen on few next steps. So we again start with the first element, compare it with 2. We swap it, so we have 2, 3. After this, we will compare 3 and 4. In this case, 4 is greater than 3, so we do nothing at this step. And we start to compare 4 with 1. 4 is greater than 1, so we swap them, and we will have like 1, 4 at this step. So, as you can see, after 2 iterations, we have 2 last elements in the order, but previous one is not in the order. Like, on next iteration, we will start with 2, we compare it with 3. 2 is less than 3, so we doesn't do anything. Then we compare 3 and 1. 3 is greater than 1, so we swap it and put like this. So after this, we have 3 elements in the end that are in proper position. And like on last iteration, by the same way, we will have all elements in proper order. So from 1 to 5, like this. Is it clear how algorithm by itself works?
Well, I think yes.
Nice. If some of viewers have questions, please feel free to ask.
Yes, and send comments if you something didn't understand.
Great. So let's understand what complexity of this algorithm. The complexity of this algorithm will be next. First of all, it doesn't store any additional memory, so memory complexity will be O1. We just swap 2 elements, like it depends on language or whatever, we maximum will store some temporary variable for 1 element for like temporary solution. But for time complexity, originally we will have like n square. I will explain it now why it is. So we are going through array like on the like first iteration and until the elements go to the end. In worst case scenario, we have array ordered like in the different position, like 5, 4, 3, 2, 1. And we repeat this operation like for every element. So until 5 go here, until 4 go here, 3 will be on place, so it will not change. So we repeat this operation n times until like every element will go to proper position. So we have like n elements for every iteration, and we repeat it n times. So we end up with n square in worst case. But I want to mention that sometimes for some type of so if we know how elements are ordered in right now, bubble sort can be optimal solution. For example, if we have array like let me write it like 2, 1, 4, 3, 5. It will work from like one iteration. We will swap 2 and 1, we will swap 4 and 3, done. We do it under n. So like in best case scenario, we will able to do it under on. But it's only for like this best cases. Generally, algorithm measured for worst cases. There are also other kinds of measurement for algorithms when they to use and so on, but generally we focus only on worst case. So like it's guaranteed that we will not do it for longer than this one. Like it's nice to do something faster, but we won't have some guarantees. Generally, other like optimal sorting algorithms able to give guarantee time of n log n. Log n, you know how logarithm works, right?
Mm-hmm.
So I will just explain. If we have, for example, 1000 elements in our array, logarithm of 1000 will be around 10. So it will be like 10,000 operations for array of 1000 elements. But with bubble sort, it will be like 1000 to 1000, it will be 1 million operation. So 1 million operations, again 10,000. It's like huge difference. But I hope later on we will learn better algorithms for sorting and like implementing them.
I hope to.
That's all for theory for now. Let's go to our task and see what we have here. Let me zoom in a bit. So we have already implemented bubble sort here. Like we have some code. And we getting some array of integers, and we need to sort this array using bubble sort. But what is required here is to answer with the next thing. First, we need to answer how many swaps we do. So swaps is these ones. So when we swap two elements with each other. Second one, we need to return the first element of array. Third one, we need to return a last element of our array. So here is example with 6, 4, 1. We go through this, and like after first operation, on first operation we swap 6 and 4. So we go with 4, 6, 1. Then we swap 6 and 1. We go like 4, 1, 6. On the next operation, we swap 1 and 4. So we end up with sorted array of 1, 4, 6. So we do it with 3 swaps, and we're done. really I doesn't see any problems with this task, so I doesn't know what to ask. Usually I ask you how you will solve it, but like it's already with answer. What do you think about this? Alexei?
I'm sorry, can you repeat?
As for me, it feels like we already have an answer what to do. It explain like everything, like do a sort and count how many times you swap elements and just return it. So maybe it's this task is more about coding itself and not about finding the proper solution. But just as introduction for sorting, maybe it's good. So.
Yes. I
Um,
like to hear your voice and your explanation.
Great.
Is it sound is it sound normally?
I hope so. So let's go for implementation. So we have a function, and this function we receive array itself. And in the end, we will need to write 3 lines of text. Let's start with them. So we will write it to console. Hope this will works. Generally, there is different outputs. Usually, one of them is console. Console usually use it for debugging and such things. But there can be also like normal output. But usually for tasks, here console is fine. So we will have swap count at initially 0. We will enter swap count to this text. With this type of strings, we can enter variables like in the text with these symbols. So we just enter variable name and it will appear here. So we also will need to enter the first element of array. Let me call it at least R. Doesn't like 1 letters for the variables. So we will get the first element of array and we will get the last element of array. To get last element of array, we will see the length of array and remove 1 from them. So for example, if array have 3 elements, the last index will be 2 since we start from 0. Okay, so right now we will need to do the sort itself for this array. I think we can start with copying provided code and refine it for JavaScript, because this is written not for JavaScript. For example, it uses like integers instead of let. Maybe that's all. So we also will need to do a swap itself, swap of elements. So we are going from the first element to, I think n is size of array. So let's rename it our length. We go from the first elements until the last one. Then for every element we repeat this operation. We go to the last one. Well, also there should be like -1. To the last one we compare these 2 elements. Let me rename J to another letter. I usually use some letters that are not similar, because with ing, they look similar, and you can like misunderstood which letter you are currently using here. So we need to perform swap operation of these two elements. To do this, we will add the temporary value, as I had told before. So to remember one of the elements. So we will remember temp. We will remember element of also it's not a, it's should be array like this. So we will remember the k element, and we will need to switch it with the k plus 1. So the first element will be equal the next element, and the next element will be equal to our temporary value, like this. And we will need to increase our swap count. And maybe that's all. So let's try to run our code.
I hope it's... Oh, wow!
Yeah, from first try. So we can submit code and
you are
see.
good in this, I think.
We already have a solution for this one. So we can do small optimizations here, just to be it a bit better than it right now. So for example, we have array of that already in order. So we have 1, 2, 3, right? We can like stop, or right now our algorithm will work like n square times every time. So it's like for every element we repeat this operation, that's all. But we need to do operation only if we had swap at least once. At least one element was swapped like previously. So let's modify our algorithm with this information. So we make additional variable with that will determine had we swap something or not. Initially we doesn't swap something, but if we swap something, we set it to true. And like after this cycle, we will check if we doesn't swap anything. This means not. If we not swap, so say like if we have false, not false will be true. So this will execute it. We will break our cycle. Break keyword stop the cycle from executing and just end it from where it is. So if we doesn't swap any element, we stop our array like right now. Okay, another thing that we can optimize here, like every time inside we go from 0 element to the lastest one. So like from first one to last one. But like after each operation, one of last items go to the place, right? So we have 4, we have 5, we have 4, we have 3, and so on. So like we don't need to check the last element. On the second iteration, we don't need to check last 2 elements. Then we don't need to check 3 elements, and so on. So instead of going to the last elements, we can go like, for example, if there is only 2 items left unsorted, we can go only for 2 of them, and that's all. So instead of going to like array length -1, we can remove our first index in additional. So it will be like -I -1. Let's try. Processing. Sometimes it's took some time. So for the first iteration we have 0, and we will go up to the last element. On the everything is fine. On the second iteration we will have 1, so we will go up to we will use only 4 elements and so on. So every time we will use less amount of elements, so it will work a bit faster. We will still have the same complexity, still the same time complexity, but faster is faster. And in good cases, we can end up with less operations and so on, which is good. So we can stop for today, maybe. I think this is good point. Since we solved task, we explain theory. Everything worked good. What do you think?
I think you are great today.
Nice.
You some kind of gut, but a little bit lower, but you are good today.
Thank you a lot, Alexei. So thank anyone for watching. Leave comments if there is some questions or any suggestions, and have a nice day.
And don't forget about like and subscribe this channel.